Hello, everyone. Welcome back to City 17 and week 2 of school at home. So, last week, you remember we learned about logs and properties of logs. And this lesson today will be review for you. We did this before we went on spring break. So, I'm not going to go into every little detail about this. If you check your notes, you have a lot of this in your notes already. But I think it's a good idea to review some of this. Our topic today is we're actually going to use some logs. Well, in a second, we're going to use logs in a real practical way. Okay, but so we're going to talk about logs and how to use it like in a real world situation. And we're also going to look at X. I have to write so slow with this. Exponential growth. Wish those birds would shut up. Growth and decay. Exponential growth and decay, and we're going to use logs in a practical manner today. All right, just a little note on this. If you are doing growth, then you are going to have a positive rate. If you are doing decay, you are going to have a negative rate. That'll make a whole lot more sense in just a second when I show you the formula. We're going to start with the formula. Here's the formula, the one and only formula that you need to know. Our formula for exponential growth or decay looks like this. I'm going to actually take out when I showed you this in school, we were putting the T in the brackets here, but I think that was confusing some of you. So we're just going to leave it as capital A equals little a times 1 plus, okay, or minus the rate raised to the T power. If you are doing a formula with growth, so something's growing, like a bank account is growing, a population is growing, a certain virus that I won't mention, the rate of that is growing, then you would use plus, okay? So growth is 4 plus the rate. If you have something decaying, such as, oh, here's a good example because we're in the game Half-Life. If you have the half-life of an element, you would minus the rate, okay? If you were paying interest, your minus rate. A population is decreasing, you would minus the rate. Those are all instances of minusing the rate instead of adding. You need to memorize this formula right here. I went through this the week before spring break. I actually went through what each of these mean, but just a quick recap. I'm not going to write them out. Big A is the final amount. So when you're done calculating your thing, that's the final amount. Little a represents the amount that you begin with, your starting value. 1, well, in this case stands for 100%, but it's always 1. The rate, okay, the rate is the percentage that the thing is growing or decaying at. You always have to write the rate as a decimal in the formula. You cannot put percentages in the formula. T stands for sorry, I just realized how dirty my nails are. They're pretty dirty. T stands for the amount of times that you are going to get bank interest, or the amount of time, the amount of years, or it's the amount of iterations that you're going to do your thing. So you have to look at the case of bank growth. You have to look at whether you're getting quarterly interest, monthly interest, daily interest, yearly interest, whatever. That's going to affect how you calculate the T. Let's start with a really easy example. I'm going to leave that there. I'm going to do my examples over here. Let's start with a really easy example. Let's say that I have $4,000. I have $4,000. I'm going to invest that in some sort of either a savings account or CD or some sort of investment where I'm just putting the $4,000 in and I'm going to get interest. Let's say that I find some type of investment at a bank or something, and let's say they will give me 2.25% interest, and they're going to give me this interest on a quarterly basis. Quarterly basis. So I'm going to put in $4,000. This is my interest rate I'm going to earn, and the bank's going to give me interest every quarter. We're going to use the formula here. We're going to use this formula, and we're going to figure out how much money. So this will be question A. We're going to do two parts to this question. This is the easy part, okay? We're going to do an easy question, then we're going to do one a little bit more difficult, okay? Easy question. How much money would I have in this account if I waited for 2 years? So after 2 years, not how long, I was distracted by that bird, sorry. After 2 years, how much money would I have in this investment? We're going to use this formula right here. Now, like I told you guys in class, I always like you, even if you think you kind of, you can do this, it's a good idea, just always write down the formula, because it helps you to remember it. It helps you to get it in your head and remember it. So big A equals little a, 1, and this is going to be a plus rate, because, what is making that horrendous noise over there? 1 plus the rate raised to the t power. Hey, I'm trying to do class here. Whatever was making the noise out there, be quiet. We're just going to take our information, and we're going to fill it in, and we're going to calculate what we would have. So big A is what I don't know. That's what I'm trying to figure out, is how much money would I have after I do this. Okay, so big A is what I'm trying to figure out. Little a, that's what I started with, $4,000. That's my little a. That's what I'm beginning with. And then I'm going to do 1, and I'm going to add the rate. So here's our first question that we have to worry about. Remember I told you when we were doing the formula here, you never put rate in as a percentage. You can't put a percentage in a formula. We have to figure out how to write this as a decimal. Some of you should know how to do it in your head, but just in case you don't, let's use this as our scratch pad over here. The way you figure this out is you do 2.25. I'll show you two ways. You just simply divide it by 100. Okay? And if you divide this by 100, you're going to move the decimal places 2 to the left. Okay? So you can skip all that and just think about, just move the decimal point 2 to the left. Okay? So that would be 1, 2. So my decimal point is going to be right there. That means I would need to put a 0 right there and a 0 in front of my decimal. So that's what it would look like as a percentage. So 1 plus my rate is 0.0225. That is 2.25% written as a decimal. Now t, what is my t? Gotta be careful here. We've got 2 years. Remember, the bank has given me quarterly interest. How many times a year is quarterly? How many quarters are in a year? That's 4. That's 4 quarters in a year. I'm leaving it for 2 years. So I'm not just doing 1 year, I'm doing 2 years. 4 times 2, that's 8 quarters. So I need to raise this to the 8th degree. So our first step is, we can obviously put that together. So let's do one more step here. 4,000 times 1.0225 raised to the 8th power. Now I'm going to show you a little trick here so that you don't lose accuracy when you calculate this. Now remember, PEMDAS tells us that we cannot do this times that first. We have to take care of the exponent first. So exponent comes first. Take your calculator, type in 1.0225, and then raise it to the 8th power. I'm going to write this down, but I'm going to show you how to skip this step in just a second. You're going to take that 1.0225, raise it to the 8th power. You're going to put that in your calculator and get an answer. Okay, the screen's going to go black here for a second because I need to just check my notes because I don't know what that answer is off the top of my head. So I apologize for the screen going black for a second. When you put that in your calculator, you're going to get 1.195. 1.195. Oops. 1.1. Oh, my floor is not set right. Just a second, guys. 1.1. 1.195. Now I wrote that down, but I don't want you to do the step because if you do the step, you're going to lose accuracy because you just lost a whole bunch of decimals. So the way that you don't lose accuracy is you put the 1.0225, raise it to the 8th power, and then you leave that sitting in your calculator. That answer, it's going to be this, but there's like, I'm going to put dot, dot, dot. There's a whole bunch of other decimals. Leave that number in your calculator. Just leave it there. Just hit the times button by 4,000 and see what you get. So if you multiply that without, like I said, don't round it off and write it down here. You don't want to lose accuracy. So take your calculator, get this answer, then times it by 4,000, and that will be what your answer is. Which is, you do it right this time. I just have to check my notes. That's going to give you 4779.32. 4779.32. So 4779.32. Now I rounded that, obviously, to the cents. You want to round this because it makes sense to round it to 2 because you're dealing with money. So after 2 years, you will have $4,779.32. I mean, that's not bad. In 2 years' time, you gain, $780. That's not too bad. Let's take a look at a more difficult question where we use logs. So this will be question B. This one's going to be a little bit different because I know this is easy. That's super easy. Everybody can do that. You just plug numbers into a formula and get an answer. Let's ask a different type of question. What if we change the question to, instead of giving you a time of 2 years, let's say that we want a specific amount. Let's say that I intend to just leave this money in this account until I have, let's say, how long would it take me to get $6,500? So I want to know, how long would that take? How long? How long? How long will it take? I can do better than that. Hold on. How long will it take to have at least $6,500 in my account? I'm going to use the same formula. Let's do a different color just to make it. We're going to use the same formula. So my formula is still going to be big A equals little a times 1. Now this is a growth situation, right? So we're going to add the rate. We're growing here, not shrinking, to the t. And I'm just going to use that formula again, and we're going to write in what we know. Okay, this one's a little different from this one because, wait, let me get myself centered here. Okay, it's a little different from this one because instead of not knowing what we're going to end with, we know what we want. We want to end. We know what the end is. We want our answer to be 6,500. So I know what big A is. What I am starting with didn't change. It's still $4,000. Still starting with 4,000. The rate didn't change. I'm still adding 1 plus. Now remember, we changed our percentage into a decimal. We're still adding 0.0225. Now, what is it we don't know? It's the t. The t is what we don't know. We don't know how long. How many quarters is it going to take to get $6,500? This is where we're going to bring in logs. You'll see that in just a second. So remember, I want to start isolating this t and getting that t all by itself so I can solve the problem. The first step I'm going to want to do, okay, step one. First thing I want to do is I can see I can get rid of this 4,000 that's attached to this thing, right? So let's divide out this 4,000. That's step one. If I divide this side by 4,000, I must divide the other side by 4,000. So on this side, it's easy. I have 4,000 divided by 4,000. That is 1. 4,000 divided by 4,000 is 1. And 1 times that is not going to change it. So in other words, it just cancels. On this side, you're just going to take your calculator, put 6,500 divided by 4,000, and see what you get. You're going to get 1.625. Now, what's left on the other side? On the other side, we have, let's put that together. 1 plus that is 1.00225. But it is raised to the t power. So the question is, how do I now get rid of an exponent? If I don't know what the exponent is, how do I get that by itself? The answer is to use logs. Remember, what do logs do? What do logs solve? Logs solve exponents. So we're going to use logs. What we'll do is we'll take the log of both sides. So we're going to do the log base 10. We're going to do base 10 because we want to be able to use our calculator. Log 1.625 equals, and we're going to do log base 10 on the other side. Log, remember, if it's base 10, I don't have to write the 10 in there. Log 1.00225 raised to the t power. Now you might be wondering, well, how does that help me? I still have an exponent. But remember last class I taught you 3 properties? One of the properties was called the power property, right? Remember the power property? What does the power property do? The power property lets me take an exponent, okay? It lets me take an exponent, and what does it let me do with it? It lets me move it to the front of the expression, and it becomes a multiplication instead of an exponent. So let's do that. So we're going to do the power property, and we're going to move the t to the front. So now my equation is going to look like this. Log 1.625 equals, we're going to move that t to the front. So t times log 1.002. Whoops, I made a mistake. Too many zeros. Hold on. Get rid of that. 225. Now, if you look at our equation now, you will see we no longer have any exponents in our equation. It's all multiplication. And that's exactly what we want to be able to solve this. So our next step then is, remember, our goal is to isolate that t by itself. Well, the t is attached to this by multiplication. So that means I can divide out whatever I want. I'm going to divide out that log 1.02225. If I divide that side, I must divide the other side by the same thing. Log base 10, 1.02225. So on this side, this, something divided by itself becomes 1, and 1 times t is still t. So in other words, they cancel each other out. So I'm left with, so you can see what I'm left with. Let's just see what we're left with. I'm going to come up here now. So you can see the only thing that's left is we have log base 10, 1.625 divided by log base 10, 1.0225. And all that's left on the other side here, after we cancel, was a t. So now I can solve for t. I just need to figure out what that is. So again, you're going to take your calculator. In your calculator, you're going to press the log button. It's going to open a parentheses. You're going to type in 1.625. You're going to close the parentheses. If you don't close the parentheses, you will get the wrong answer. Then you're going to hit the divided by button. Then you're going to hit log. And in your log, you're going to put 1.0225. Hit enter, and it's going to give you an answer, okay? I can't do that in my head, so I need to check my notes to get the answer. So when we divide that, it's going to give you, if you round it, 21.82. 21.82. So you will get an answer of t equals 21.82. Now I rounded that off. It's actually 21.81 something, I think, is what it was. Okay, I rounded that off to 0.82. Now, we're not done here. When you get this answer, you're not done. Did that answer the question? We want to know how long. Well, is that an answer? It's going to take 21.82? What does this mean? I'm going to let you think about that for a second, okay? I want you to think about, I'm going to give you a minute. I want you to think about, I want like an answer, a real answer. How long is it going to take for me to have 6,500? This is what I got for t. But I need give me an answer, like we had over here, you know, like I want an answer in years and months. How long is it going to take? I'm going to give you a second to think about that. While you're doing that, I'm going to go here and maybe bother the birds or something. Maybe we'll throw some bottles at some people on the street or something. Let's see, who's down there that I can hit? Oh, there's a combine soldier. See if we can hit him. Let me come over here. Let's see if I can hit that fella. Yeah, pretty close. No, I can't quite get the distance. So I hope you're still thinking about that, what I'm trying to ask you. How long is it going to take? Come over there. See if I can hit those people. Yeah. No reaction. Anyways, okay, did you come up with an answer? Let's check. Okay, so what you have to remember when you're answering this is that that's not really an answer. Our investment is by quarters. The bank gives me interest every quarter. Now, at 21.82 of a quarter, the bank is not going to give me my money. They're not, okay? Because they're only going to give me interest every quarter. So what you always have to do is round up. You can never leave an answer like this when you're dealing with t. Always round up. No matter what this says, always round up. So we're going to call t 22, but these are 22 quarters. 22 quarters. I mean, most people can't think of how, you know, that. I mean, I know that is 22 periods of 3 months, but people don't think like that. Let's get this in an answer that makes sense, okay? How many, well, a quarter there's 4 quarters in a year. So let's think about, what can I times by 4 and still be under 22? Well, 4 quarters times 5 years would be 20 quarters. So I know that if I had 5 years, so that's at least 5 years. 5 years would be 20 quarters, and I'd have 2 quarters left over, okay? Well, how much of a year is 2 quarters? 4 quarters in a year, 2 quarters is half a year. How long is half a year in months? 6 months. So this is a much better answer, because I can understand that better than saying 22 quarters. So it's going to take, so to get at least 6,500, I mean, that's the mathematical answer right there, but realize that the bank doesn't give me interest on that date. So I have to wait till the 22nd quarter, so I'll have more. I'll have more than 6,500 because I'm past the mathematical answer. But I will have to wait till 5 years, 6 months to have $6,500. And that is how we can use logs when we're dealing with an exponent in our question where we don't know the answer. Your classwork is on the page right below the video that you're watching right now. Just go below, right below there. I tell you what to do for practice work. As always, I want you to do the practice work from the PDF file. I want you to do the practice work on paper. I want you to save the paper. Towards the end of April, I'm going to ask you to upload some of these on Canvas for me to look at to make sure that you've been doing your classwork. But for this week, you don't need to upload it. You just need to do the quiz after, and the quiz is based on the questions that are out of the PDF. So make sure you do the classwork first, then do the quiz. The quiz will be going in the gradebook. If you haven't looked at your gradebook yet, I want you to notice that I did put last week's assignments, what we call quizzes, I did put them in the gradebook for classwork. So they are uploaded, they are in there. You can go look and see how you're doing for your grade. There will be another lesson on Wednesday, and then we are done the unit on Wednesday. So we will be having, I haven't decided yet, we might have an actual quiz, just so I can get a quiz grade in the gradebook, or we might go right to the unit final. I haven't decided yet. But your unit final for logarithms will be coming up soon. We have one more lesson on Wednesday. Okay, stay safe, guys, and I'll see you on Wednesday. Goodbye.